Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome to another episode of the Smart City Podcast. I'm Jim Frazier, Vice President of Smart Cities here at ARC Advisory Group. And today, I'm thrilled to welcome Austin Wilson, the Velodyne Director of Intelligent Infrastructure. Austin, can you tell us a little about your career journey, what led you to work with lidar, intelligent infrastructure, and perhaps even a little bit about Vision Zero?
Absolutely. Appreciate having me on today, Jim, and giving me the stage to talk about some of the work that Velodyne and I are up to. It's greatly appreciated. My background of how I got where I am today is probably not the traditional type of route that you hear from people that are working in civic innovation or government innovation or traffic safety or anything like that. I actually, as a college dropout that started my own company, which I then sold and exited about a decade later. And after that, I wanted to get into the tech world just because I had a passion for technology. A couple of years before that, I had an experience of unfortunately being hit by a vehicle in Los Angeles while I was on my skateboard. And through that experience, I started to really try to, on my own, understand how organizations, at the time thinking organizations, not local governments, make decisions on corrective actions on how they can make roadways safer for vulnerable road users. At the time, I didn't think about it at that level, but after being hit by a vehicle, you tend to notice things on the road more and think about things a little bit differently. And so in my journey of getting into tech, I started working for a company called Urban Leap, which is a GovTech startup based out of San Francisco. And through that, I kind of fell in love with working with the public sector and understanding large problems that are within communities and how you can leverage technology to then understand those challenges and potentially solve them through X, Y, and Z. And so for me, I fell in love with that whole aspect of problem solving and leveraging technology to help us understand the outcomes. And after working at Urban Leap for several years, I branched out and started my own consultancy called GovTech Labs, where I would advise GovTech companies about how to scale their product into the public sector ecosystem at the local and state level. And through that experience, Velodyne LiDAR was a client of mine, and we started launching several projects. And they came to me with an opportunity to join them full time and help them continue to launch the intelligent infrastructure solution and effectively be the general manager of the market for Velodyne. And the rest was history. And so I've been full time with them for about 5 or 6 months. And it's honestly the opportunity of a lifetime to be able to use my passions and the things I'm excited about to work on every day and deliver those safe and meaningful outcomes to communities around the world.
Wow. Well, thanks, Austin. For those who might not be familiar with the technology and in fact, the acronym, can you talk a little bit about, what is LiDAR? What does that acronym stand for? And, what is Vision Zero?
Excellent question. So LiDAR, the acronym stands for Light Detection and Ranging. So think of sonar, which is, sound, radar is radio, LiDAR is light detection and ranging. So the technology is it's skin and eye safe, and we use laser beams to create a 3D representation of a surveyed environment. So LiDAR, quote unquote, sees in 3D and provides a very high resolution point cloud in real time for a wide range of environments through day, night, rain, or snow. The way that I kind of like to say that easy is it lets computers have vision. It enables computers to have computer vision. So your drone, your robot, your autonomous vehicle can actually see. And Vision Zero, not so much to do with LiDAR, but Vision Zero itself is a strategy to eliminate all traffic fatalities and severe injuries while increasing safety health and mobility for all. And this was first implemented, I think, in Sweden in the 1990s. And Vision Zero has been a pretty big success across Europe, and now it's gaining a ton of momentum here in America. And I think there's probably like 65 to 70 cities that are now committed to Vision Zero and trying to meet, specific goals by X year to, again, reduce and eliminate all traffic fatalities and severe injuries on their roads. And I can't remember exactly what city. It might have been Oslo, but I believe in 2020 they had 0 vulnerable road user deaths because they executed on their Vision Zero plan well. And over the course of a decade, they were able to reduce that down to 0, which is pretty wild if you really think about that.
Yeah, that's almost unbelievable. Austin, let's talk a little bit more about lidar. You're saying it's computers will have vision. Most of the human vision is two-dimensional. Is lidar two-dimensional, or would you consider it multi-dimensional? Does it give us actual distances and shapes?
Oh, absolutely. It's definitely three-dimensional. So as the laser beam leaves the lidar sensor, it bounces off an object, bounces back, and then creates a 3D image of its environment to tell you how far away something is, its trajectory, how tall it is. And then you can take all of that data, as we do, process that on the edge, and then we send that data to our cloud so our users can then experience that data, that 3D data that the lidar sensor creates, and make informed and prescriptive decisions based off those data sets about how to fix intersections, arterials, highways, and things of that nature.
Well, okay, Austin, anytime anyone mentions vision and camera systems, there's a privacy concern about facial recognition and situations like that. Does lidar suffer from those same challenges in the public perspective?
So it does not. Something that I talk with our city partners about is the fact that lidar has no bias in terms of the human being or the object or animal or vehicle or whatever it may be that it sees. So as cameras at an intersection, there's a lot of civic unrest with putting 4, 5, 6 cameras at an intersection. You got 1,000 intersections around your city. You got cameras everywhere. There could be facial recognition. They could be taking facial biometrics, all sorts of different things. LiDAR doesn't do any of that. LiDAR doesn't see skin color, eye color, hair color, or anything, right? It just sees, let's say in this circumstance, we're talking about the vulnerable road user, it just sees the human being. So it's a great technology for cities to leverage to not break the community's trust.
Oh, that's good. So that leads to my third question. So what challenges do you see in this intelligent transportation market that LiDAR maybe uniquely addresses?
Well, safety for one, sustainability, efficiency, equity and privacy concerns. As you and I were just discussing the privacy concerns, the front part of that where I said equity, cities right now are looking for solutions that are systemically safe throughout their communities, meaning they don't want it to just work in one community. They want it to work in every facet of their community. Now, I live in Kansas City, Missouri, currently. We have a pretty diverse community here in KCMO. For example, if you go about 10 blocks east of where I currently live, the life expectancy is about 18 years less than where I live. That's not that far away from where I live, yet it's a 17-year difference. So when you're talking about, let's say, the communities that are east of where I live in Kansas City, those are the communities where people are underserved, can be underappreciated, undervalued. And unfortunately, you get a lot of people, let's say, darker skin complexions in Kansas City who live in those communities. As we were talking about earlier, Jim, a lot of these accidents happen at dusk or at night or at dawn. And unfortunately, a lot of these vulnerable road users are hit by these vehicles at that time. So when you're talking about equity, if my technology can work in any community the same, because it doesn't see the human being or the eye color or the skin color, it can be equitably distributed to drive innovation and systemic safety throughout a community, which is extremely, again, valuable for communities these days to scale technologies throughout an entire community to deliver outcomes, not just a portion of a community.
I'm intrigued, Austin, that you mentioned sustainability. How does your solution really, what sustainability components does it impact?
So one aspect of the technology, and this is not even necessarily too much to do with the lidar. The lidar data enables our cloud to give this data to the user. So it's called green allocation, which is how much of your green lights are allocating users and how often. So as our system is detecting, let's say, red lights, green lights, and yellow lights, we can leverage that data, or a city can leverage that data and say, wow, this light, people are rating at this light for 65% of the time at a red light, instead of driving for 30% of the time at a green light, and maybe it's 15% of the time at a yellow light. If you can start to reduce the amount of time that people are waiting at red lights, you're effectively reducing the amount of CMO2 that let's say intersection is producing from cars that are just waiting. That's kind of why we have that new technology. When you see new cars, they're at an intersection waiting for the green light, and they hit the gas and they turn back on. That's the automotive world trying to say, how do we mitigate emissions at red lights, where our technology can actually quantify that specific intersection and then offer data sets to say this is what needs to happen to reduce your CMO2 or your emission outputs.
Wow, that's a great example. That's fascinating. With that example, you're focusing on actual vehicles. Safety, when we think of safety and most of the impacts of deaths and injuries, it very often it falls on to pedestrians. And as we know, pedestrians don't like to wait. Many of them, in fact, in the most optimistic examples, 25% of them will actually press the crosswalk button, and only 25% of those will actually wait for the crosswalk to turn green. I'm supposing that's probably some low-hanging fruit for the Velodyne system.
We could call it low-hanging fruit. I guess that's an interesting term, but yeah, I suppose you're correct there for sure.
Okay. So can you tell us then, perhaps in a little more depth about Velodyne's intelligent infrastructure solution and the all the technology behind it? Because I know it's not just the lidar sensor itself.
Yeah, absolutely. So we launched in May of 2021, and we keep calling it the Intelligent Infrastructure Solution. It's honestly a mouthful. We call it IIS for the sake of conversation. So IIS is this breakthrough hardware and software technology utilizing best-in-class AI, which is actually from our partner, BlueCity.ai. And they're a small company based out of Canada, and we had a lot of goals, and our mission really aligned with theirs. And so a partnership was very easy to come upon. And then the entire idea is to make cities safer, more equitable, and greener. And so how that works is, again, IIS creates, as we were saying earlier, that real-time 3D map of roads and intersections, providing really precise traffic monitoring and analytics. And it reliably collects all of this data in lighting, weather, and conditions of all sorts, supporting 24/7, 365 operation. To kind of unpack that a little bit for you, we talk with some state DOTs, and some of their systems aren't detecting and picking up data for about, let's say, 4 to 6 hours at night, because the cameras they have, unfortunately, in ambient lighting don't, let's say, function that well, or heavy snow or heavy rain. And so if you're thinking about a system that's collecting data, but it's missing 20% of the day because of X reason, that's 20% of your day that you're missing data every single day, every single year. Whereas LiDAR isn't going to be having that issue, and our solution goes 365, 24/7. And so IIS that's advancing safety through multimodal analytics and detects road users like vehicles, pedestrians, cyclists. We can tell the difference between trucks and trailers and all sorts of different vehicles. And it can predict and diagnose and address road safety challenges, helping municipalities and some of our other customers make those informed decisions and take the corrective action.
So the components of the IIS package is the field LiDAR sensor array, and the AI package, and the connectivity between those. How do you manage the connectivity between the sensor and your AI cloud?
So it's actually it's pretty elegant. So we put our sensor up on a pole, and we only need one sensor per intersection. This is our rotational. This is our 32 channel ultra puck that we put up on the traffic pole. And we have a PoE up there that's powering the actual device. And then we also have an edge box. So the edge box, think of it as a supercomputer, is processing all of that. I mean, LiDAR produces a massive amount of data, as you can imagine. So the edge box is actually processing all that data in real time. sometimes this box goes in the traffic cabinet, sometimes it goes on the pole, just depending on a few other circumstances. But after all that data is processed on the edge, then it's sent up to the cloud, where a city can then leverage that data to make those decisions. So it's a full suite of the sensor and edge box, and then analytics.
Does the AI work? Does it do calculations based on adjacent sensors that might be on sequential intersections on a road?
So in terms of like our system, or are you asking in terms of like other systems that are on the road?
Oh, in a custom configuration, is this a point-to-point monitoring system per intersection, or does this also help in say eco driving, where I'm sensing a collection of vehicles coming down a road, and I would like this signal to turn green, and then a quarter of a mile down the road, the next one can anticipate those vehicles coming down the road?
Yeah, so I love that question, Jim. So I've been talking about this with my team a lot lately, and so we're looking at a digital twin type of model. So we can manage intersections. We have traffic actuation. We can create virtual loops, which effectively can replace inductive loops. And when we're thinking about creating these digital twins with a sensor at an intersection, and then let's say it's just one block away from the next intersection, you have multiple blocks of this. By putting a sensor at each intersection and then putting a sensor at mid-block, as long as we can fuse the LiDAR data, we can create a digital twin to give a city or any of our other partners a really, really clear understanding of how all of their routes are moving. And from there, we're not doing this now, but this is kind of just a wacky idea I've been thinking of is, can we put sensors on buses? And as buses are actually going around the city, those buses are connected to our intelligent infrastructure, and all that data from what the buses are picking up, because now we have moving assets, not just LiDAR at fixed positions at intersections. Can those buses detect new graffiti on a wall and then automatically send that data to Public Works, telling them they need to go, let's say, clean that wall off? Or can it detect a pothole, and then as that bus is on its route every day, measure that same pothole, and as it gets to a certain size, notify the needed department within the city to go and fix that pothole? Again, that's kind of future state, but I like your question just because we're really thinking that way of how we can create a full view.
Yeah, the perspective I'm taking in my thinking in asking that question is that there is connected vehicle technology, C2VX, V2V, that is starting to be implemented in new vehicles where there's a message set that has very low latency but only goes 100 meters. And there is, one of the more impactful technologies there is in fact eco driving, where the vehicle can inform the traffic signal that, hey, I'm coming. And if a number of vehicles inform the traffic signal, we're on our way, maybe it'll stay green a little bit longer to allow you to pass through. Or the traffic signal itself can tell the vehicle that I'm turning red. Why don't you just coast into the signal? That's a great technology, which is not part of autonomous driving, but the adoption rate is going to take some time, particularly when the average age of a vehicle out there on the road today is 11 or 12 years old.
Yeah.
So that's all well and good, but it's going to take some time. So in a way, some of this fixed infrastructure can really do that kind or a similar kind of work very, very quickly and easily without waiting for that adoption rate.
Yeah, I mean, you're absolutely right. So we're working on a project in Helsinki right now. We are working with Comsignia. They are our RSU partner who we are integrated with overseas right now. And we have one of our sensors at a specific intersection, and we have a couple test vehicles. And so the idea is, since one of my sensors can be placed at an intersection but detect at all four approaches, if a vehicle is approaching that intersection, I can send data from, let's say, my system to the RSU, from the RSU to the OBU that's in the vehicle, and now the vehicle knows where all the pedestrians are on the street. So as somebody's coming up to a crosswalk, the system will actually let the vehicle know before the human being will even see the person in the crosswalk that there is somebody that's going to be there. In parallel, when the car meets that crosswalk, well, I guess it's not parallel, it's perpendicular, but you know what I mean. When it meets that crosswalk, if it's turning left or right, and being that my sensor is at that fixed position at the intersection, whether or not the car is going right or left, it's going to know where people are before it makes that turn. So now a car knows where people are around its environment before it even makes a turn. We're really just trying to test the data accuracy and efficiency.
It is early for that, Austin, but that's a great stepping stone to the full implementation, because today that V2V chipset is actually in your cell phones, and in a perfect world down the road, if your phone is on and you are walking through the crosswalk, your phone will send that message 100 meters to the vehicle that's bearing down on you. Mm-hmm. But that hasn't been turned on in current generations of phones, nor is it in every vehicle yet. So this really is a great, intermediary step. That's great. I'm looking forward to hearing how that develops in the next weeks and months.
Yeah, absolutely.
Yeah. How about, can you share any details on city partners that are utilizing your solutions, and what are they finding?
Yeah, absolutely. So some data sets I can share, some I can't necessarily mention. As I was talking about earlier, we have an install in Boca, where you live, over at East Palmetto Park in Ocean. Oh, yeah. And the install is on the southwest corner. So, man, next time you're over there, look up and, snap a pic and send it over to me, because I haven't seen it up on the pole yet. So you could help us with some marketing content there. And what the city was trying to accomplish a few things, but something that was important to them was that that's on Ocean, right? So you get a lot of people that are walking across from the beach, walking across the street to where those hotels and restaurants are. And they had let's say an aging population there that crosses the street a little bit slower. And so they wanted to use a system that could hold traffic for, let's say, somebody who is in a wheelchair or somebody who is elderly and, gets across the street a little slower. And so that was kind of their first step. And, how can we use a sort of technology to detect people crossing the street and hold the lights for those vulnerable road users? And then from there, it spiraled into a bunch of other, things that we're doing with them now. And we're also working with cities like Austin, Texas. And we're working with them specifically to help them achieve some of their Vision Zero goals of eliminating traffic fatalities and severe injuries. And we are deployed at Springdale and 7th. I feel like that's the installation. Jason John Michael would kill me if I got that wrong. But we are actually deployed at an intersection. I believe the data is that 70% of the intersection accidents that happen within Austin, Texas, happen at the actual intersection where we are deployed. And so we are working with the city to understand near miss detection, red light running, and a lot of other data sets, so that we can say, well, how do we redesign this road? What do we need to do here in order to make the street safer? And we were actually out in Austin, Texas, a month and a half ago. We were at the South by Southwest event, and IIS actually won an innovation award out there. And we went out to go see the installation because none of us had seen it in person. We were all really excited, and we wanted to take pictures, and it was a really big moment for us. And it was a very sobering experience to roll up to the intersection, and 30 feet east of the intersection was a shrine of flowers where somebody clearly had been hit by a vehicle and killed at that, necessarily at the intersection, but about 30 yards back from the queue, I want to say. And it was a very just big reminder of why we were doing what we were doing. And it was a very impactful moment for me and probably the entire team that was with us. And, we're also partnered with the city of San Jose, helping them deliver meaningful outcomes and meet their Vision Zero goals as well. I can share a fun little anecdote with you. One of our partner cities actually was able to detect that one of their intersections, they had buses, they had trucks and cars just blowing through red lights. And we could say, well, this is how far after the red light, the truck went through it. So when you have trucks or cars or buses going through red lights 2 or 3 seconds after the red light, it's a big warning sign as to what the heck is going on. Usually is not just based on driver behavior. And then our system also told us that this was happening within like the same 45-minute window every single day. So this is the world of like proactive and reactive in terms of traffic safety, is that the city leveraged that data to understand that there were near misses happening because of the red light running. So our system fused the red light running data together with near miss data, which is what we call post encroachment time, which is the mathematical equation of when one object enters and leaves another area and another object enters and leaves that exact same area. When do they almost hit one another, right? And so that data is extremely important for cities to have to leverage to understand before accidents happen. So the system said red light running, near misses are happening. It's at this time of day. So the city sent someone down there at that time of day. And what we were able to deduce was there was a glare that was coming off of a really big building, and people were heading west and they were getting blinded because this was at dusk, as we were talking about earlier. And so people weren't seeing the light change from green, yellow, red. And so looking at this data, we're thinking, God, well, how do we solve this challenge? Like, my technology doesn't solve that challenge. It gave the city the data sets to understand that that problem is happening. The actual solution to the problem was planting trees that were tall enough to block the glare. So that right there is like, that's the definition of urban innovation, right? We leverage technology to understand a problem, but planting trees was the solution to stop people from running red lights and then almost hitting people on the road. I mean, how cool is that?
Austin, because I do live in Boca Raton, and I am familiar with that intersection. It's fascinating that the variety of road users there that you mentioned, really, I never thought about it this way, but it is very broad. You not only have the seniors who are walking slower, and some do have assistive devices like wheelchairs and walkers and things. But you have a very active community of road biking people, and sometimes you have 20 or 30 bicyclists in a clump. You have a playground right at the intersection as well, where a lot of kids are coming back and forth. You also have a fire station, and a lot of people walking and biking to the beach as well. So knowing what I know about LiDAR, I'm supposing that you can do a fairly good job of identifying each of those different kinds of users, whether it's a pedestrian, a single biker, a group of bikers, or perhaps even someone dragging a cooler to the beach.
Yeah, absolutely. We can detect all sorts of different road users. That's the perception software and the AI that's able to really detect that, which the LiDAR enables the software to do that. You also have tons of people on scooters. When you talked about people on bikes, there's the other aspect of there's people on electric bikes now that go like twice as fast as normal bikes. So you have people on the same type of, let's say, vehicle, which is a bike, going twice as fast. It's Florida. I mean, I lived there for a while. I mean, I rode around with my shirt off a lot. People aren't wearing leather jackets or anything like that. It's a little different, right? So I think that in environments, I mean, Boca made a really smart decision by putting that sensor there to really understand if it can help them solve challenges before they scale it. And that's really what I liked and appreciated about Boca's approach to their community was we don't want to just buy this and just hope that it works. We want to take this approach to understanding the data sets it can offer, how we can leverage those data sets to solve challenges around our community. But let's prove this works at one intersection before we actually scale it. And I love that approach because it mitigates risk of failure. It doesn't waste taxpayers' dollars. And it really helps the city understand at a more holistic level how to sustain that innovation and deliver those outcomes. And, Boca, as you said,
that's going to be a fascinating application. It occurs to me we left out one road user that comes to mind is the ubiquitous golf cart community we have down here as well.
So, not to say we couldn't train our AI to learn what a golf cart is. We could absolutely do that. We had a scenario in Austin, Texas, where we had trucks going through an intersection, but these big black blobs were just going through the intersection, and we couldn't figure out what the heck it was. And then we kind of figured, we're like, wow, like this is Austin, Texas. There's lots of people with trailers with horses in it that are on the back of trucks. We need to train our AI what a trailer is so that if there's a near miss, somebody's almost hit by a trailer or something like that, we can identify that it wasn't just the vehicle, it was like the trailer that's attached to the hitch. The same thing happened with trolleys. And in the city we deployed into, these big blobs were going through the intersections. We realized those were trolleys. And so we had to train the AI what the trolley was. And it's actually pretty amazing how quickly AI learns. It's pretty cool.
Okay, so Austin, what type of technology competes with LiDAR? LiDAR is not the only sensor that you could put out there in the field. What are the challenges within the industry that you see for those existing technologies that LiDAR in fact solves?
So I'll start this by saying, I'm certainly not bashing any of the other technologies that I mentioned right now. There's pros and cons to everything in life, right? When talking about, let's say, like LiDAR versus cameras, the cameras produce 2D images. We were talking about before, we were talking about this 3D images. Well, we live in a 3D world. So getting data at a 3D level can be a lot more accurate and say timely than that 2D data. And mentioning cameras again in those low lighting conditions, or for people at night that have darker skin complexions, again, camera struggles to see in those ambient lighting settings, or if it's heavy rain, or if it's heavy snow, where in those moments, that's where LiDAR can actually shine. That's kind of, that creates its own life source. So I didn't mean to, make a pun there, but this is really where LiDAR shines, is within those current environments. And when it comes to LiDAR versus radar, like cameras, radars face similar challenges. The technology is not refined enough to accurately identify objects like LiDAR can. In addition, radar's resolution or image clarity is relatively poor compared to LiDAR. So, I see cities leveraging cameras and LiDAR at some intersections. I see them leveraging camera, LiDAR, and radar at some intersections. Some intersections maybe just will have LiDAR, no cameras. Well, that probably won't happen. But in the circumstance of all of those technologies, if I can deploy one LiDAR sensor and get the same type of coverage as 4 to 6 cameras, or let's say 4 to 6 or 6 to 10 radar sensors, just one LiDAR sensor is already saving the taxpayers of whatever community tons of money in hardware. If you're deploying at 100 intersections, it adds up pretty quickly, as you can imagine. And again, kind of going back to I guess, like the cost of it. Our goal is to continuously lower the cost of LiDAR, so it becomes easier for governments to introduce to their communities. And then, of course, there's privacy. This is one of the biggest things that we talk about with our city partners, is that as we're going to the fourth industrial revolution, and tons of innovations are being deployed, and all this emerging technology is going to be hitting the streets, especially with the infrastructure package that just got written in. Public trust and data protection is an ever-growing public concern, and where camera necessarily doesn't mitigate that, LiDAR certainly does.
Austin, you bring up cost, and I'm not looking for any hard and fast numbers, but there's been a perception, LiDAR, and we know costs have been coming down in recent years, due to Moore's law. And just that's the way semiconductors go. But can you give an idea of the order of magnitude of cost between, say, the installed cost of 4 cameras, 1 at each mast arm at an intersection, versus 1 LiDAR sensor today? Is it roughly equivalent? Or what could you say about that?
Well, coming to hardware, it's going to be a lot less to deploy 1 LiDAR sensor opposed to 4 cameras. 1 camera may cost the same as 1 LiDAR sensor, but being that camera is only 2D, you have to put 4 cameras at an intersection to get that full 360-degree view. So from a hardware perspective, it's already going to be economically beneficial for cities to look to start deploying less hardware. Also, it looks prettier with not so much crap up on you all over your traffic lights and your poles and whatnot.
That's a very good answer. And it's not the installed cost. A small part of that is actually the hardware. It's the continuing maintenance and the truck rolls to adjust 4 different cameras that often get windblown and bent over and get environmental impacts.
Yeah, I mean, it's a good point. We have a sensor up in Canada. I want to say it's up in British Columbia. I can't remember. It might be Edmonton. And we literally have had that sensor at the exact same position for well over a year through multitude of different weather conditions. If you remember last year, we had a pretty warm summer in the Northwest. And of course, the Canadian winters, you can imagine, are pretty brutal. Our sensor, we haven't had to go in and clean it once. We haven't had to adjust it once. It's been pretty amazing how resilient that little sucker has been up on that pole.
That brings up, I know that with LED streetlights, their life is very long. It could be 10, 20 years. So the major maintenance issue becomes cleaning the lens. Is there a suggested time to clean the lens?
If you have a LiDAR sensor on a drone or a robot or a vehicle, they're lower to the, well, not a drone, but I guess a robot or a vehicle, they're lower to the ground and they're moving. So it's easier to get dust that's kicked up. I was talking with the Iowa DOT the other day, and they were showing their Velodyne sensors that are on one of their autonomous vehicles, and it's Iowa, right? So they're not just testing this in their urban environment of Des Moines. They're testing this out on dirt roads. And when you have an autonomous vehicle on a dirt road, well, that lidar sensor gets kicked up pretty dang quick, as you can imagine. So when it comes to different technologies, there's different measures for cleaning and let's say the sustainability and durability. For us, with our lidar sensor, that's up, let's say 15, 20 feet in the air up on a pole, it doesn't get a lot of dust kicked up on it. It doesn't get a lot of interaction. It doesn't move. It sits completely just still. And so right now, every day that goes by is just kind of more data saying this is how long this little sucker can last. We're very much not in research and development, but we're very much of a proving of concept and a pilot phase of this technology. And so with all the projects we launched, we're obviously learning a ton of new things, but in all intents and purposes, when we've had sensors out in Florida in the summer, they're not malfunctioning. When we have sensors that are in Canada in the coldest winters, they're not malfunctioning. Nothing's needing cleaning. Nothing has malfunctioned yet. Not to say it won't happen, but we're about a year and a half into this. So that's the data I can give you for now.
Oh no, that's great to know. I know that in the early days of LED streetlights, the heat issues were challenging because there's a tremendous amount of heat that needs to be dissipated when you're running an amp or two in a streetlight. And in that, the basis of my question really does come also from the streetlight world, where there actually is a calculated dirt depreciation factor on light output for streetlights. And occasionally it's suggested to ride around every few years and do a pressure wash of your lens. But I'm guessing your sensors are robust enough. They're with a 5 or 10% degradation, it works the same.
Yeah, absolutely. I mean, it has to, right?
Right. So let's move on to some somewhat forward-looking issues. Traffic safety is often said to be reactive rather than proactive. How is Velodyne lidar a proactive solution?
So the way that, and I talk about this a lot with our city partners and with traffic engineering and civil engineering firms we work with, traditionally speaking, there's an accident on the road or at an intersection. And then that data can take, anywhere from like 6 months, maybe sometimes even a year to get in the hands of somebody that needs to analyze that data to understand why the accident happened and what needs to be done to fix that intersection. Well, if it's because of poor design or because of new technology that's on the streets like scooters, or maybe it's something that is repetitive that could be fixed that's causing this accident, over the course of a year that somebody's waiting to analyze that data, what if there's more accidents for the exact same reason, right? So it's kind of the reactive world of an accident has to happen in order for a organization to analyze and then fix that intersection. That's all reactive, meaning that if you're just going to be reactive, you're never going to stop something before it happens. And so in the world of IIS, the post-encroachment time algorithm that we have, which is the near miss detection, can tell a city, you haven't had 6 people hit at this intersection. You've had 6 people almost hit at this intersection. Just like that story I was telling you about by one of our partner cities detecting red light runners and near misses, that was a city understanding that this was happening prior to an accident happening, right? That's the whole proactive, mindset of we're actually going to understand the data before anything is happening to the people on our roadways. And so that's, in my mind, that's the easiest way to kind of explain how we are taking the public sector into the future of giving them the correct data set so they can proactively solve challenges for the community.
That's fascinating. This brings up a related question of, does your sensor look only at the roadway or also to adjacent sidewalks?
Oh, it's roadway, sidewalks, the whole shebang.
That's interesting because I am a bicycle advocate here in Boca, and I don't want to speak for the city, but There recently, I believe, was a study of bike accidents, and a variety, many of them, particularly in the downtown areas, happened on the sidewalk because the bike lanes were inadequate and were not, a 5-foot marked bike lane. So the rules developed that are being developed are now looking at why are accidents happening on sidewalks and driveways rather than in the bike lanes. So this is interesting. It could pick up those scenarios as well.
Yeah, absolutely. I have data that I could share with you just showing bikers blowing through red lights, right? Like, and you see that quite often. Like bikers, they're in a flow. They don't want to ride at a red light. They're just going to check that it's safe, and then they're going to cross the street because they're on a bike ride. Admittedly, I do that with my bike when I know it's safe to cross the street. So if a city can understand, let's say bikers are, running through these red lights, and let's say there's near misses, a city would be able to detect that and understand why those near misses are happening, and then again take action to fix X, Y, and Z at said intersection. And also, obviously, that goes for sidewalks as well.
Austin, this has been a fascinating discussion so far today. As we're nearing the end of our time, let me ask, what do you see in the future for LiDAR in general and Velodyne in particular?
So a few priorities here, really driving down the cost of LiDAR technology, making LiDAR ubiquitous, providing solutions that make the technology easy and easier to deploy in urban or rural environments, really maximize and deliver an excellent customer experience, their ease of use, world-class service, et cetera. And continue expanding LiDAR applications in automotive, widespread infrastructure, and of course, industrial and robotics uses.
So Austin, we're just about out of time. Do you have any parting thoughts for our listeners?
Something that kind of that got me into this whole world was, I didn't really understand my local government as much as I do today. And going back, let's say 6-7 years, when I was very much of a novice in my understanding of what my local government does for me, I encourage any sort of listeners to engage with their local governments and understand who are the people that are driving innovation and who are driving sustainability and all these other, big buzzwords these days that cities and everyone is using. And, a lot of people that work for your local government, they're not politicians. Most people that work for the local government, none of them are politicians. They all choose to work for the government. And these people are overworked, they are underpaid, they are undervalued, and they have a really hard job. And so I would encourage any of the listeners to really start to dig into their local communities and understand who is doing what and who is in charge of what, other than just the politicians, and really getting into different programs and helping your local government understand how they can help you, the citizen, deliver a better outcome to your community. So that's, I guess, my parting thoughts, I suppose.
I will second that very often those public workers are looking for input from stakeholders. And they really do try to collect those perspectives and see which ones have consensus. And if it's about bike and pedestrian safety at a particular intersection, well, they usually do their best to try to rectify those problems.
Yeah, absolutely. And it's also something to consider, which is, the government at the local level does not have a move fast and break things mentality, right? It's don't mess up, don't waste taxpayers' dollars. Everything has to work, if not heads roll. And so, I'm excited to see the culture of local government and, DOTs and state governments change with allowing more of a culture of failure where people can learn and feel safe, innovating, right? In innovation, there's a level of failure that it has to be accepted. Me personally, I'd rather know that Kansas City is going to go below $100,000 of taxpayers' dollars testing new technologies, opposed to putting something to RFP for $20 million. Then it fails because they didn't test it and they wasted $20 million. Like I would rather hear my local government, being willing to take those risks, and it's really cool to see that change happening slowly.
Well, today we've talked with Austin Wilson, Velodyne Director of Intelligent Infrastructure. Austin, before we go, how can listeners contact you?
You can email me at awilson@velodyne.com, or you can reach out to me on LinkedIn. There's probably about 2,000 Austin Wilsons, but hopefully I'm up there at the top.
Well, thanks, Austin. This has really been enlightening. I thank you very much. I thank you all our listeners, and hopefully we'll see you again on another episode of the Smart City Podcast.
Absolutely, Jim. You're the man. Thank you so much for having me on and allowing me to tell our story.
It's our pleasure.
Broadcasting from Boston, Massachusetts, the Smart Cities Podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.